I really do hope that the animation I drew on here, on this slide, help you, some of you, not everyone, but some of you see the anti-periplanar, right? And how it rotates, you get another anti-periplanar conformation. Anyway, it took me like 3 to 4 hours, just 3 or 4 slides. It's really difficult to rotate this bond right here. And all the animation, right, is really difficult, man. This class is killing me easily. This is supposed to be a 16-week long class. The preparation is tough still, but it's not like as congested, right? Like 4-week class. This is difficult. Jeez. Anyway, I'm dying. All right. So this is kind of hard to see, but let's let's practice together. All right. So all you have to do is to be able to see an anti-periplanar from the bond line structure. All right. Now, what do we have to do here? Find an anti-periplanar beta hydrogen. So a beta hydrogen that anti-periplanar of the leaving group. So everything relative to the leaving group. Okay. Draw a curve the arrow to represent an E2 process and draw all possible elimination products. Okay. All right. The first one right here. So we have a leaving group right here. There's an alpha, beta position. No on the right. No hydrogen on the right. One hydrogen on the right. On the left, all right? We have a methyl group point on a wedge, so the hydrogen gonna be on the dash. If you can see, this is an anti-periplanar, okay, position, conformation, right? So bromine point toward you, hydrogen point away from you, so they're the opposite basically. That's an anti-periplanar position, conformation. All right. So which means that you can do an E2 on this hydrogen and get rid of bromine from double bond in the middle, all right? So take a third butoxide from right there. Do the E2. You should get that single product there. That's it. Because this hydrogen is the only beta hydrogen that we have. Good. Right. Yeah. There's only beta hydrogen. There's no beta hydrogen on the right side. That's a phenyl group, the benzene ring. All right. Now in B. All right. So bromine point up. Look for beta hydrogen. So this is alpha. This is beta. On the right side has no hydrogen. So just ignore it. All right, methyl group point down, wedge. So the hydrogen gonna be point up on a wedge line. All right, this is totally not an anti-periplanar, right? Because syn coplanar basically. Have Tuskegee look through this bond. Bromine gonna be on the left side, point down. Hydrogen gonna be on the left side, pointing up on the second carbon. Like that. Bromine bottom left, and hydrogen on the upper left. Okay, top left, I mean. All right, so this is syn, kind of syn, not really a coplanar, but it's a syn conformation. They're on the same side, right? So syn coplanar, you cannot do E2 with it. Because, you have to make these two, hydrogen and bromine, on an anti, right? So you have to rotate this carbon-carbon bond, right? How to do that? One thing you should realize that who's anti right now? Bromine and methyl group. That bromine and methyl group. All you have to do, rotate the back carbon, move hydrogen to replace methyl, methyl to replace phenyl, and phenyl group replaces the hydrogen. All right, same thing right here. So hydrogen here replaces methyl group, going to be on the dash line. Methyl group going to go down to replace phenyl group on just a bond line structure on a paper plane, and the phenyl group going to go replace hydrogen on the wedge line. All right, so rotate like that. Take a look right here. One more time. Take a look right here. One more time. So hydrogen replaces methyl, methyl replaces phenyl, phenyl replaces hydrogen. Go right there. If you do this conformation, that's an anti-periplanar. You know that? All right. Same thing down here. Once you rotate, hydrogen gonna go to the dash. Methyl gonna go down to the paper plane, and the phenyl gonna go up to the wedge line. So 60 degrees. All right, 60. All right. From here, so that's an anti-periplanar. So you can do an E2 there, and you get Z isomers, cis isomer, whatever. Right. This is trans. This is cis, and that's the only one product that you will get. There's only one hydrogen, only one beta hydrogen you can do. Okay. All right, we have, so this is a difficult concept. It's kind of hard to see the anti-periplanar conformation. So practice on here. This is just for you. All right. And, there's the solution right here. All right. One solution. It's kind of long. Hold on. It's just explanation. That's the reason why it's long. A, B. So step A, step B. So this all step B. Look through this. You should see that, all right? And then you're gonna rotate. So this is chlorine and hydrogen on syn right now, and then go to anti-periplanar. So they rotate chlorine front carbon. Chlorine move there. Hydrogen move to replace the third butyl. Third butyl replaces chlorine. Okay, and from this conformation, you can do an E2 and you get this product there. All right. Okay, let's go to the next video.